everyone. Thanks for joining us, and welcome to today's online summit, Maximizing Your AWS Cloud, which is sponsored by NetApp, the world's leader in data management solutions. I'm John K. Waters, Converge 360's editor-at-large, and I'll be your host for the first of 3 sessions for what promises to be an extremely enlightening summit. Today's summit was organized by the editorial staff at the 1105 Media News sites AWS Insider and Virtualization and Cloud Review, who brought together some extremely knowledgeable presenters. More about them in a minute, but first I need to go over just a couple of housekeeping details. Today's summit is being recorded. Keep an eye out for an email coming your way with a link to that recording, which you should feel free to share with your colleagues. Our sponsor, NetApp, has provided some resources that can be found on the right-hand side of your console. Please take a moment to check those out. And there will be a Q&A toward the end of each session. You can type your questions into the Q&A box at any time. Please feel free to add your questions as they occur to you throughout the presentations. We'll do our best to get to all of them. And last but not least, at the end of the 3rd session today, one lucky attendee will be receiving a Nintendo Switch, he tried to say, Nintendo Switch gaming console. Second best-selling console ever. You must be present to win, so stick with us. Now on to our first session. What's new in AWS? Let me introduce you to our presenter, Stephen Smiley. He is Director of Cloud Services at Intervision Systems, an AWS Premier Consulting Partner. He focuses on enabling innovation, making it accessible and actionable instead of a roadblock. A former military intelligence officer, Stephen balances strategic and tactical thinking to help you accomplish your objectives. Needless to say, we're in for an informative session. And I'm so excited to welcome Stephen. Stephen, take it away.
Hey, thank you, John. Thanks for having me today. So today we wanted to talk about what's new in AWS. And what I'm hoping to do for everyone here today is kind of sift through a lot of the announcements and the new things that everybody's been talking about and try to bring to you what I think are the most valuable things and how you can get started with those. As John said, I'm a Director of Cloud Services at Intervision Systems, and I really try to help people do a variety of things in AWS. So I can help set up comprehensive security, AWS landing zones. We do a lot of migrations of existing workloads into AWS. I also do cost optimization of existing workloads to help you save money. And I like to do new development of serverless applications that really take advantage of AWS's services. And so I really, in that way, kind of run the gamut of all the things in AWS. And so we're going to talk about some of the things that I'm interested in and I think are most valuable that have come out recently. You can connect with me on Twitter at Stephen Smiley or on LinkedIn if you want to connect with me and talk about some of these more later. And of course, I've got the AWS certifications to back up some of this knowledge. So let's get into it. The top things that I wanted to discuss today are on the screen here. Okay. The IAM Access Analyzer, the Web Application Firewall bot control features, a new container deployment service, App Runner, the latest application migration service, Incident Manager, Step Functions Workflow Studio, and this Cloud Development Kit version 2. So first, let's talk about IAM Access Analyzer. IAM Access Analyzer has existed for a while, and you may or may not have used it if you're in AWS. In fact, I find that it's one of the services that people don't seem to get into. I'm not 100% sure why, because it actually can help a lot. It for a long time has been able to help you identify permissions and resources that can be used by external entities. So let's say you've got an S3 bucket and you really, really want to know that this is a private bucket, right? This can't be accessed by another account or publicly. IAM Access Analyzer will help you say that definitively. But beyond just S3 buckets, any other resources that you have, you want to know whether or not that can be accessed outside your account. And so IAM Access Analyzer helps a lot with that. But one of the challenges with doing that is that a lot of us write broad IAM policies in order to just get the thing to work, right? So what IAM Access Analyzer can do now is this can help you both start better policies and refine them later. So one of the new features that they have is policy validation, where this has over 100 checks. So as you write a policy, you can check it, and it will tell you if it has errors, if it has security problems or security suggestions, or just other general suggestions for how to make your policies better. And we're going to look at what those look like here in a second. You can use this either in the AWS console, or you can also use it on the command line. So you can use the command AWS Access Analyzer validate policy and send it a JSON policy, and it will send you back the results of that validation. So this is something that if you're not already using, you should start looking at. But the other feature that it's going to help you do is refine those policies based on actual usage. So you write a broader policy, you make sure the thing works, and you use it for a couple of weeks. Well, now that you know you're not going to change it anymore, let's go back and based on your CloudTrail events, right, based on what it's actually seeing you use, it can generate a least privilege policy based on that. So that's really powerful, right? Because if later those permissions somehow get compromised, now they're not more broad than they need to be. So let's take a look at what this looks like. Here's what we're going to see in the console for IAM Access Analyzer. And you can see right here, there's an error where there's JSON syntax, a parse error, and there's an extra bracket that doesn't belong on line 3. And so it's giving you a little red X, and it's saying, hey, there's an extra bracket here on line 3. You don't need it. So that's really helpful because you don't need to be worrying about syntax errors as you're trying to write secure policies, right? Let's look at a security example. So this policy is a really common one. I see this a lot. IAM get role, IAM pass role. So the IAM pass role action allows you to pass a role to some other resource. For example, I've got an EC2 instance I want to start an EC2 instance, and I want to start it with permissions to do something. Well, in doing that, I have to pass it a particular role. Now, that doesn't necessarily sound like a big deal, but what if my permissions are really limited, and I have pass role to resource asterisk here, pass role anything. That means that I could start an instance and pass it the administrator policy. And then once I log into that instance, I'm administrator. So I've just escalated my privileges. And so for this reason, pass role with star in the resource is just basically always a bad idea. The resource should be limited to what roles you can pass. And so now IAM Access Analyzer is going to give you that heads up, and that's pretty powerful. This is what it looks like when you're going to go to refine a policy based on your usage. So you can give it a time period of specific dates, like you knew an application was active, or you can say, the last 5 days, last 1 day, whatever that is, and then use a particular CloudTrail trail that you have set up. And an important point here is that you have to have that CloudTrail trail set up. And I'm sure we all do have CloudTrails already set up, but if you don't, that's definitely one of the things that you have to have, not just for this to work, but for general security in AWS. So try this out, particularly on service roles. So if you've got an external application that's connecting to your account and it's using an IAM user to do that, a lot of times those are asking for very broad permissions, but you don't have control of those credentials. So scope those down as much as you can, and this is the way to do it.
Please stand by as we reconnect our presenter.
This happens once in a while. We'll have Stephen back in just a sec. Just a reminder, you can enter your questions into the Q&A box anytime.
Please proceed.
Okay, thanks. I'm back. So we talked about IAM Access Analyzer. Let's get into the new features for the web application firewall for bot control. This is actually really interesting because what AWS has found is that over 50% of the traffic hitting web apps is from bots. So let's get a handle on that, right? It can analyze the TLS handshake, HTTP attributes, source IPs. It analyzes this information, and it can try to figure out what those bots are doing. And not all bot traffic is bad, right? Sometimes you want it, right? A search crawler or something checking that your website's available, and that's okay too. But most of this you really don't want. You don't want bots just scanning you for security problems, or just hitting your website for no good reason. So you can choose based on the different types of bots that it is detecting, whether to block it, whether to return a tailored response to it, or insert a new header just so that your downstream application can handle it differently. You can also add labels that you can use in future rules for like a web application firewall rule so that now you can handle it differently. Or you can also put it in your CloudWatch metrics and just measure how much of your traffic is genuine traffic and how much of it is just from bots. One of the main reasons to do this is to reduce cost by blocking this at the edge. If your application is hosted on EC2, for example, and you've got an auto-scaling group, and this bot is hitting you and making your EC2 instances scale up, why am I paying for that, right? Let WAF bot control block that at the edge. It doesn't even get to your instances, and so you're not paying for it. The other reason is to save performance. So, okay, you've got your thing in an auto-scaling group, but I still don't want this scaling up more than it needs to. I don't want it handling a bunch of requests from bots that I'm not interested in. So block it at the edge, and now your application can perform better. The best part of this is that the pricing is really, really reasonable. The free tier of this covers 10 million requests. So for most small applications, you're really not going to be paying very much at all. After that, $10 a month plus a $1 per million requests. To me, that's a really reasonable amount to filter out unwanted traffic. And here's a look at the CloudWatch dashboard that you're going to get with it. So you can see that it's separating it by regular requests and allowed and blocked bots, and it'll even give you a sample of the bot categories. So you can see that at the bottom there's social media versus like Canary. So it will give you some helpful information about this. And then you'll know, I mean, hey, if your traffic spikes for some reason, did you end up just getting a lot of genuine traffic? Or did you somehow end up on a bot's list and now you're getting hit? That's something that you definitely want to know if you're running a web application surveying the public. So let's get into this next one, which is App Runner. AWS has, a dozen ways to run a container on their services. There's support in Lightsail. There's obviously the Elastic Container Service, EKS for Kubernetes containers. You can run them on EC2 and just configure it yourself. So what's the right way to do this? Well, App Runner is the result of combined efforts from the ECS team and the Elastic Beanstalk team. Elastic Beanstalk is the service that helps you kind of run code for particular stacks in a really simple way. So they found common patterns that people wanted to do that didn't fit into either one of their existing services. So they said, all right, we want to make this easier to employ. And we've got to look here at what it looks like. So the main two things that you can choose are your source. So you could either point it to a container registry, whether that's in the AWS container registry or Docker or somewhere else, or you can just point it right to your source code. So I think in a lot of cases, the teams are going to want to point this right to their source code. You can connect it to GitHub, point it to a registry, ask it which branch is your main branch, and it will hook into that repository and say, hey, anytime that this branch is updated and pushed to, I need a new deployment. And then you configure the rest of the service settings. So you say, hey, I want this much CPU and memory. I need these environment variables, right? So this is my production environment, or this is a development environment, or whatever other environment variables you need. And right there, you've got built-in auto scaling. It performs health checks. It supports custom domains. And so this is kind of an easy button for running a containerized app. Let's talk about how this compares to other services, because that's the big question, is like, which one do I use? Is this right for me? So if you compare it to Fargate, which is, the engine underlying ECS that you can use, the difference is that App Runner will let you build and deploy directly from your source code repository, and you get a public endpoint with all the supporting infrastructure. If you do it in Fargate, you're gonna have to configure the rest of that. It's not impossible or even really difficult, but it's going to take more AWS know-how. And if you know that you don't need that, then App Runner is going to make it very easy. One of the other things to know is that you can combine App Runner with the App2Container tool, which can containerize common web apps. So you've got a Java or a Spring Boot web application, and it's not already containerized. Well, App2Container is designed specifically to go and containerize that. And now you run it in App Container, and you've got immediate continuous deployment, auto scaling, and monitoring that you didn't have before. So that can be pretty powerful if you've got an existing application. The other container service that I'm pretty excited about is AWS Copilot. And Copilot is actually more of a tool that helps you deploy ECS patterns. But you can use App Runner as a deployment type through Copilot, and it'll let you get more customization. But the major difference here is that it's going to keep all the bundling on the AWS side. So if you do Copilot locally, it's going to do all this bundling on your machine, so client side, and that's just not ideal, right? So it's much better to let AWS handle that on their end. So you can combine Copilot with App Runner, and I think a lot of development-focused teams who do not want to necessarily become AWS experts are going to like this a lot for getting their application out so they can continue focusing on development. All right, so the next one we want to talk about here is the application migration service. And this is an interesting development because AWS acquired a tool called Cloud Endure in 2019. And if you've done migrations into AWS, you've probably run into Cloud Endure. But there was always something that was a little uncomfortable about it because even though AWS owned it, it was not integrated into the rest of AWS. It was Cloud Endure by AWS, and I don't think that people felt the same level of confidence that they did with other primary AWS services. And so they had server migration service, a database migration service, and that's what a lot of people went towards. But now, application migration service is the rebranded name of Cloud Endure, and it is the primary migration service. It's been integrated so that all the APIs are consistent, and it is right there available in the console, and we're going to take a look at what it looks like here in just a second. And it integrates with all the other AWS services in Migration Hub and so forth. And so this is the way to do migrations on AWS now. I strongly recommend that you stop using the server migration service. It's not as good, and that is why AWS bought this and built this new one. The process overall is pretty simple. You're going to install the agent on each of the source servers, and then this service will continuously replicate those systems into AWS. It sends them to a staging area which is sized down so that it's got lower cost. And then when you're ready, you cut over to production and it ramps those up, and then you're good to go. And as long as that tests and works just fine, you can decommission your old servers. And I think the best part of this is that it's free for 90 days. Right, except for obviously the provisioned infrastructure that you're building, but the service itself is totally free. And some people have said, yeah, but that's only 90 days. Well, I got to tell you, don't stretch out migrations too much longer. You really don't want to be stuck in a migration for half of a year or a year. It'll slow everything else down. Make this your focus for 1 quarter, get it done, and I think you're going to be happy with the result. So let's take a look at what this service looks like when you're using it. As I said, you'll be able to pull this up right here in the console, application migration service, and get started. The first thing you're going to do is add your source servers. So they have pre-made scripts that'll run on any system that you really can realistically migrate in. As soon as you run those, it will, it installs the agent, and that agent calls back to AWS, connects, and it will appear here in this list of servers. And so you get all those added up, and then you go into each one, and you basically tell AWS how you want this to end up. So you say, all right, I want this instance type. This is how I want the operating system licensing. So whereas we see here on the screen, it's going to bring your own license. So if it's got a license, you can bring it. But you may be able to transfer that and do the licensing through AWS for simplicity. You can say, all right, I want to copy the same private IP. I want to bring server tagging over. And this is the network I want to move it into. And this is the disk size I need. So you set all of that up right here. And then once you're ready, you can actually launch test instances, either one at a time or in groups, however it makes sense for those servers. So you see here, I'm checking 2 servers, and I can see that the data replication is healthy and that they're ready for testing. So I'm going to launch a couple of test instances. make sure that they're working, and then when they're ready, I just say, hey, cut over. And if I run into any issues, the best part of this is that all I have to do is go and click and say, revert. This is not ready, right? These didn't work, and I don't want to be running this in AWS until I figure that out. Personally, I haven't run into any issues during this stage, but I'm really, really glad that I can revert that easily. And then the other part of this is that this is going to keep track of your migration progress across all of those services. So you can see this per server, but then you're also going to get a roll-up of how many do I have in each stage. This is really nice because you're going to have different people on your team responsible for different servers, and you want to have one kind of source of truth for how are we doing here. And this is going to give you that. This is going to give you the ability to see which ones of these are giving me trouble, which ones of these are easy, we can decommission, and it's going to be all in one place, and that's really, really nice. So I just feel like that made migrations a lot easier. But then once you're in AWS, you're going to start talking about, all right, well, how do I manage these and control them the way that I did on-prem? Well, the first thing you're going to go to after migrating a bunch of servers has got to be Systems Manager. Systems Manager helps you do patch management, send commands, open sessions, SSH or RDP sessions to those servers, and just generally ensure that those are managed appropriately. You can also get application inventory and set compliance. So Systems Manager is going to be your go-to place. But the thing that AWS didn't have until recently was some way of managing incidents. So if something happened, to a server where it was having an issue, there was no central way of managing those incidents, which seemed odd, right? Because we do this on-prem. Many of us have a third-party tool, and so we were continuing to use that third-party tool. So finally, Systems Manager has added this capability called Incident Manager, and to me, this fills a major gap in their offering. So with Incident Manager, you're going to define your contacts and channels. Say, these are the people, and this is how I want you to reach them. And you're going to define escalation plans, which is really important, right? Because what if that contact isn't available? I need to be able to escalate appropriately. And you can also build a response plan. And this is going to be a combination of who do I contact? What is the escalation plan for this? What is the runbook to respond? And where are we going to collaborate when this happens? Which is important, right? Because you don't need people texting back and forth. We want some chat room where we can all work on this together. And the response plan that you've just defined can be triggered either manually or automated. So CloudWatch Alarm or Event Bridge should be able to trigger this response plan when it observes an issue. So let's take a look at what this looks like. You're going to get this dashboard during an incident, and we're seeing that we've got a DynamoDB issue detected on the sample app. The application is extremely slow. It's reported by monitoring and users. The write latency alarm was triggered in CloudWatch, and so that triggered our response plan. We've got a timeline of events. We know down to the second, when did this incident start? When did we update the summary? And what are we doing on it? And we can see what is the impact of this? How long has it been going on? So in this case, we're seeing a 4-hour and 47-minute duration in the upper right. So we know how long it took us to resolve this. And that's going to be important for you to be able to kind of reflect on how well did you do with this, and overall, how are you doing with incidents? So it's also going to keep track of the various metrics that are relevant and any other related items. So as you're going through, you're going to do some detection, some diagnostics, and after the incident, you want to analyze what happened and you want to document how you responded. This is how you get better at handling incidents and how you get better at preventing them, right? So here in one place, you get to put, here's how I would detect this more efficiently, and here's how we could improve the time to diagnose this. And you fill out these questions that AWS has pre-built for you based on its deep experience. I mean, nobody has more experience doing this than AWS right now, right? Especially successfully. So they've built this for you. This is based on their internal process, and now you get to use it. So I know I'm excited to use this, particularly for my environments that are, all in on AWS. If you've got an environment and you're spread out, you've got, things still on-prem or in other clouds or wherever, I don't know that I'm going to say Incident Manager is going to necessarily fit in, because you probably want a central view of incident management, right? So your third-party tool is probably still the way to go until you're all in AWS. But I know that for a lot of smaller organizations who don't want to pay for that separate tool and don't want to set that up, this is going to be perfect for getting them kind of a robust way of managing incidents without paying a bunch of extra and having that extra complexity. So let's look at the next thing that I'm particularly excited about. So this is Step Functions Workflow Studio, and Step Functions is something that a lot of people use and really, really enjoy, but I'd say most AWS people just don't even focus on this. And it's because it's been a little intimidating and a little bit difficult to get started with. And so the Workflow Studio here helps. By far, the best way to use AWS is to write serverless apps, right? If you're just using AWS to host EC2 instances, you're not getting the most out of AWS. So once you're in there, you're probably starting to think about, okay, I should be writing Lambda functions for my compute-intensive thing. Whatever I'm doing is compute-intensive. I should be storing my data in a DynamoDB table, which is the best database to run on AWS. But and I should be using API gateway to expose, external APIs. But how do I orchestrate a lot of these things together, right? Well, Step Functions is the answer. And so it's an essential component to those serverless apps. But it's been intimidating before, because in order to write the flows, you had to write it in a JSON format with the Amazon state language. And it's not complicated, but it's intimidating. And so this Workflow Studio is going to help you get started. As you can see, you're going to visually lay out all the different steps from a start point down to an end point, and you can branch and alter the flows however you need. And so this Workflow Studio is going to help you get started. But an important thing to note here is that this is really just for getting it started, because you can't modify existing workflows. The output of this, as we're going to see, will be that JSON file that you can use in your Step Functions workflow, but you're not going to be able to come back in and modify this and edit it and change it from here, or at least not yet. But this is going to help you kind of play around and get started. So let's take a look at what a user is going to see when they're using this. So you get started, you got an empty workflow. and on the left, you'll have a list of all the available actions. So invoke a Lambda function, publish something to an SNS topic, run an ECS task, whatever that is. And then you also have the flow options that let you control the flow between those different actions. So it's as simple as kind of dragging it in, and then on the right, you've got the configuration for that item. So you give it a name and all the parameters that are relevant. So for a Lambda function here, we're going to point it to the function that we've got. We're going to tell it how to handle the payload, what is the next state that comes after this Lambda function, and then we can modify the input and output as we need. So this is what it looks like as we're kind of modifying some of those parameters. So in this case, we are configuring the output, which is going to become the input to the next step, right? So that's really important. Here, we're transforming it by really just checking, hey, is this payload validated, for example? And then that gets passed into the next state, which is going to be a choice. And so this choice is going to say, all right, if this validated successfully, then branch to the left. And if it didn't, then branch to the right. And you get to control all of those rules and flow right here in the user interface. And based on that, here we get to handle that error reliably. So if it validated correctly, we're going to go and store that account information by putting an item into our DynamoDB table, and then publish a successful email and end the flow. But if it didn't validate correctly, then we branched off to the right, and we're going to publish an item to SNS that sends a failed email and say, hey, this didn't work. And then we're going to mark this flow as a fail state and then end. So now we've got really reliable control, and we know the results of this. It's so much better than trying to handle that all within a Lambda function. Because you could imagine trying to handle that in a Lambda function, right? It comes in, it waits for the response that it does, gets it back, and then calls DynamoDB directly, sends an SNS thing directly. If I do that, it's not going to be clear to me when things failed, when they didn't, and this is just a much, much cleaner way of doing it. And so handle this logic in a workflow, and then let that Lambda function be very targeted and focused on just what it's doing. So here's the export that you're going to get. It's JSON, so it's not great at reading, but this is what's going to be what you're going to be able to put into your source control, and from here is where you're going to modify it. So this will help you understand what did I build in the flow and how I can modify it from here. I find that people don't have too much of an issue modifying an existing workflow written in this, but it's just pretty intimidating to start with a blank one. And so this helps you really helps you a lot when you're getting started. And that brings me to the next one. So this isn't new, but it's still something that not enough people are using. The AWS toolkit specifically for Visual Studio Code, which is now probably by far the most popular development environment, this is an extension that helps you do a lot of things focused on serverless applications. So we talked about that JSON that I just outputted from my Workflow Studio. Now I've got it in my source control. The toolkit can draw this diagram, so it'll draw the same diagram that Workflow Studio did. But now, as I go in and I change this in my code, I can see the updated diagram. So that's pretty helpful. And it's especially helpful if you're doing if you're looking at a change, so you're doing a code review, someone else made a modification to this workflow. Well, I don't have to just read the JSON to figure out what change they made. I can pull up that diff right here and look at the difference between these two diagrams and visually see what happened. I think that's going to make this a lot more manageable than it used to be. The other things that you can do with AWS Toolkit here are invoke your Lambda functions directly, right? So I can pull up my list of functions and invoke one with whatever payload I'm looking for and get a result. I can also monitor the logs of those. So I can pull up a CloudWatch log stream and watch that live. And I can also just explore the resources that I've deployed through CloudFormation or the Cloud Development Kit. And so I can see what I've built and all of their properties. So for a lot of people who are developer focused, who don't want to live in the AWS console and they're developing serverless applications, this is going to be a very powerful extension for them. And if you're doing serverless apps and you're not using this yet, you've got to give it a shot. Speaking of the Cloud Development Kit and writing serverless apps, the version 2 of the CDK is now in a developer preview, and I don't know exactly when it's going to be generally available, but it should be very soon because it's already very stable. But CDK is a way of defining your infrastructure using regular languages. So Python or TypeScript or even C# or Java. And it generates CloudFormation in much the same way that you're writing a higher level language that compiles down to, assembly code, right? Why would I be writing assembly code manually if I can write it in a higher level language? So in my opinion, this is the best way to develop for AWS now, and I predict this will be the future of infrastructure as code. Over the next 5 years, I expect to see this become more and more what AWS pushes as the way to use AWS. And one of the things you'll see in using the CDK is that the line between infrastructure and application is really blurred when we're talking serverless applications. In fact, you might not think of applications as serverless as much as serviceful. That's a term I prefer because really what you're doing is you're tying together the different AWS services in a way that is needed for your application. And so when you're using, quote, real languages here, you're going to find that you have unmatched power and you have concise expressiveness, readability, and testability, right? So when I write my intent, it's going to be so much easier to see in a couple lines of Python what I'm doing rather than hundreds of lines of CloudFormation where it's really hard to understand the relationships. And what that means is that if I'm reading somebody else's CDK, I can read it and make sense of it so much better than I could a declarative template. And it's also testable. So in the same way that you can write tests for Python or TypeScript or whatever, you can test your infrastructure using unit tests and integration tests, and you use the same test suite and test harnesses. So that's really powerful. But the other thing that it does is that it generates least privilege policies implicitly. So if I say I need a Lambda function to be able to write to this DynamoDB table, that's one line of CDK, and it implicitly creates the IAM role that Lambda function is using, and it only gives it the permission that it needs, which is specifically to put objects or write items into that DynamoDB table specifically, and no broad policies. That's huge. The other part of it is that you can write your deployment pipeline as part of the application. So in CDK, you are writing the pipeline and the build instructions right here, And that's really powerful. So at the end of the day, you always retain the ability to just use CloudFormation. So at a minimum, CDK covers everything that CloudFormation has. It just also has more. And it does that through this concept of constructs. So it has level 1 constructs that just match CloudFormation, basically, and all of their parameters. But then level 2 constructs are these curated components. They have sensible defaults where, your S3 bucket has encryption turned on, right? And it's blocked, public access is blocked, for example. So it's got these best practices built in. And of course, you can override them if you need to, but you're going to do so affirmatively, not just by accident. And then the best part is level 3. So these are patterns where multiple resources are integrated together for a specific use case. There's a lot of these that are publicly available. Start looking for AWS serverless patterns. They're out there, but you can also write your own. So you recognize how you're integrating these things, and you write a construct, and then you use your own construct, and it makes sense, which means that you can have your more senior people write a higher level construct, and your more junior people apply them. You can share them like a library across your enterprise however you want. This is going to allow the scalability of infrastructure in the same way that we've seen with application development. The big change with CDK version 2 is that it brings all of these constructs under a single package. It used to be that these constructs were in separate packages based on the services, and that was a little bit unwieldy for dependency management. So now they're all in one thing, and it's a lot easier to manage. Let's take a quick look at what an application in CDK looks like. So let's say I want to write a highly available containerized web service with an internet-facing load balancer on ECS using the Fargate engine, and I want to write that in Python. Well, this is what it looks like. It's 29 lines of CDK, and that includes the imports. That includes, basically everything to it. And here it is. So I'm importing the services that are relevant, EC2, ECS. I'm grabbing the ECS patterns library, and I say, hey, I need a new VPC. And notice that here on line 14, I'm saying I want an EC2 VPC. I give it a name, and I say the max AZ is 3. I want 3 availability zones. But notice how I'm not defining all of the subnets and all the route tables and security groups and everything else that would normally be associated with a VPC. It implicitly does that for me, and that's pretty powerful. Then I'm going to define an ECS cluster. And notice that all I'm doing is giving it a name and putting it in my VPC. VPC equals VPC. Just put it in there. So then on line 18, I'm saying, all right, I want an ECS pattern of the application load balance Fargate service. This is already made for you by AWS. I just give it a name. I say, this is the cluster I want it to go into, right there on line 21, cluster equals cluster. And then I define the CPU, give it a 512 CPU. I'm going to say how many counts of the ECS tasks do I want? That's 6. And then I'm going to point it to my image, which is a container image on the Amazon container registry. I tell it how much memory I want, and I say, yes, I want a public load balancer. So you can see how concise that is. I just gave it the information that really matters. And at the end, this is going to generate over 1,000 lines of CloudFormation that's in my mind basically unreadable. And if you were writing that in CloudFormation, you would have to write hundreds of lines as well. So I ask you, which would you rather read and maintain and use? I feel like everybody is going to say CDK. And so I highly recommend this, and this is the way to go, especially when you're writing serverless applications. Okay, that brings me to the end of my talk here, and I'd love to hear your questions. So what do we got?
Thanks, Stephen. That Fascinating. We've got several questions here. I want to get to them real quick, but your predictions about the CDK are fascinating. Maybe just a really, really quick question for me. In what situations, well, I don't know how I'll put this. What situations is the CDK best suited for?
Yeah, so I would say that it's for new applications that you're writing to be AWS native, right? I don't think that I would recommend trying to use CDK in a migration, for example. I've got a migration from on-prem and I'm pulling stuff over. You're not going to get much benefit out of trying to write that, in Python, right? You've already got it built. Don't worry about it. But if I'm going to lay out a new thing, I've got API gateway, Lambda, DynamoDB, and step functions, then this is the way to go for all of those like serverless purposes. And any time that you're writing things where you want a built-in kind of CI/CD pipeline for it, then go to CDK. There's even a whole library of CDK pipelines that will build the pipeline for you. And so that's helpful. I'm actually seeing one of the questions here is how does the CDK know your subnet security profile? And I think the answer to that is like, so what you're going to do is you're either going to define your subnets in CDK and be pretty careful about how you lay out your security profile, or what you're going to do is you're going to separate your network definition from your application definition. And I actually think this is a good segmentation. So you have one application in CDK that defines your network and lays it out exactly how you want. In the other one, you're basically going to go and say, here's my application, but go grab my VPC based on this like tag, right? So you got a VPC that's tagged with like high security. Go grab the high security VPC and put my application into that. And that way you could separate the team that manages the network from the team that manages the application and the life cycles of those stacks.
Fascinating. I've got a couple of bot questions. What is the unique ID of a bot on which to filter to qualify the volume?
I'm not sure I fully understand the question. The unique ID of a bot on which to filter on. So I think what you're going to get is you're going to get some different categories of bot. So I mean, I could flip back to what that CloudWatch dashboard looks like really quick. Here's what it looks like. But it's gonna categorize it for you. And I think that's the unique ID that you're going to use. I hope that answers your question.
Another quick bot question. Why are there so many bots? Where do they come from, and what are they trying to accomplish?
That is a good question. And, a lot of them are not evil, I would say, right? So some websites are trying to check that your website's available, right? And they want to have an index of when your website went down or whatever, or is it still up? And that could be a good service, I guess. And others are going to do it for kind of search crawling. They want to know, Google or any other search engine, and that's not a big deal. But a lot of them, honestly, are malicious. A lot of them are going to be looking through your directory. They're going to be looking for common patterns where, this is running a vulnerable WordPress application, something like that. And in that case, you should be patching your WordPress, but let's not give them any help. Let's not let them find out what version I'm running. I don't want to help them out as much as I can.
Right. Here's another one. What are the rules behind migrating older operating systems? For example, Server 2008, which is approaching end of life.
Yeah. So my rule there, honestly, is like if you're running Server 2008, I think you and I both know that you shouldn't be doing that anymore. It's just not getting the support that it deserves.
Right.
And so my recommendation is, connect with somebody who can help you modernize that. I think in most cases, upgrading from Server 2008 is not going to be that difficult. But you just want to test it out. And so I think if you do that, if you do that with a partner, it won't be that difficult to separate it. And you'll feel better about it. You'll feel better. Mm-hmm. And the other part of it is like if you're running SQL Server 2008 R2 or something like that, right? Where that had a long shelf life. Maybe it's time to start thinking about switching that off of SQL Server, right? And not paying for the licensing of that anymore. And the go-to tool for that would be AWS's schema conversion tool. So that's a free one that you can run. And go check how difficult it would be to update that schema to something like Postgres. If it's not that difficult, then you might be able to modernize your application and run it in RDS pretty easily. So the first step is finding out.
Quick question about application migration service. If the source server is rebooted for some reason, does the replication to staging start all over again?
No. So it does that on a continuous basis. And it does it at a block level, right? So it's going to look at the disk at a block level. It's not thinking about much inside that. So if the source server is rebooted, all it's going to do is check for the differences between what it's got in AWS and what you've got, and it's going to find the differences, and it just updates those. And that's how it can do a continuous replication without kind of constantly pulling new full images. It's just checking for the differences.
We're getting close to our time here, but let's. This attendee also asks, for the application migration service, with it free for 90 days, do you incur the cost of whatever is provisioned in the staging area? I think it does, yes. But I wanted to clarify.
Yeah.
Is that right?
Yeah, you absolutely do. Yeah. So that's why the staging area is going to be scaled down, and it's going to be actually mostly turned off. So they're not running all the time, and that's why you'll go and say, hey, I want to do a test, and it will spin up those test servers. You do your test, make sure everything's working, check that it joined your domain or whatever that is, and then you shut it back down. So you don't have to spend any more than you need to, which is good because the way that a lot of us were doing migrations before, we basically had an always-on server over there because there wasn't an easy way to spin up a smaller size. And so, that helps a lot. I'm also seeing someone ask if application migration service is repackaged Cloud Endure, and the answer is yes, absolutely. Yeah. It's repackaged and modernized. But it's a lot easier to use now. So
we are out of time. That went by so fast. Thanks, Stephen. I want to remind everyone, so that was Stephen Smiley, Director of Cloud Services at Intervision Systems. Awesome session. Thank you so much. To the attendees, remember, we'll be giving away a Nintendo Switch gaming console at the end of the summit, so stay tuned. We're going to take a short break right now, and we'll be back at the top of the hour for the second session of 3. This one's called My Top 10 Tips for Improving AWS EC2 Performance, and it's presented by Carlos Rivas. I've worked with Carlos before. He is the best. He's a solution architect at Intervision Systems, and that session will be hosted by the inimitable David Rammel, my colleague at 1105 Media. Use this break to check out those resources on your console, which are provided by our summit sponsor, data management solutions provider NetApp. We will be right back.
Okay, welcome back, everyone. Thank you for being here, and thank you to our speakers, my fellow moderators, and of course to NetApp for underwriting this summit and allowing us to bring you this great content. My name is David Rammel, editor of Virtualization Cloud Review, and I'm here to moderate the second session of our Maximizing the AWS Cloud Summit called My Top 10 Tips for Improving AWS EC2 Performance. Our speaker for this session is Carlos Rivas, Senior Solutions Architect at Intervision Systems. He helps California community colleges move their traditional data centers to the cloud, and he has worked for several large telecommunication providers, managing and configuring network devices using numerous tools and languages, including Java, Groovy, Python, Perl, and PHP. He's also a cloud computing instructor for LinkedIn Learning and Udacity. Carlos, it's great to have you here. Please take it away.
Thank you so much for that lovely introduction. And, let me get set up here. All right, everybody, as you heard my bio, my name is Carlos, and I'm a Senior Solutions Architect. I work with AWS all the time. And here's my information. In case you want to reach out on LinkedIn and connect with me, I'll be more than happy to answer questions around anything cloud related. So feel free to contact me if you have anything. Now today, what I have for you is a conversation around performance. So before we do that, I would like to make sure that we're on the same page when we talk about performance. Why is that? Because AWS has so many services and options and defaults and tons of settings that you can tweak to your needs. It's very, very simple to say, I'm just going to choose the highest possible setting for everything. And yes, you would be right. If you pick the biggest and latest and everything, of course, you're going to get the absolute possible, best performance. But of course, at the end of the month, you're going to get a bill that's going to be very, very ugly. So that's why I like to start by defining what performance is to me when it comes to using AWS services. That way, we're all on the same page. So I like to describe performance as maximizing the use of the resources that are available to you while keeping costs under control. So if you have a certain application that needs a certain amount of CPU and memory, your job is to keep track of those measurements using profiling tools and tracking tools and alarms and all that stuff, just for the sake of making sure that with this information, you can go ahead and say, okay, maybe I'm a little bit over provisioned. Maybe I can cut back a little bit and save a little bit of money while still getting the maximum performance that my application needs. So it's just one of those give and take type of games when you want to be on top of it at all times. So you'll never be done. That's the main takeaway from today, is that you will never be done optimizing for performance when it comes to using AWS services. Now, with that in mind, let me show you the areas that we're going to consider for right now. Networking, which is often overlooked, that's a very, very important one, because the reason why I call it important is because we only get one shot at doing this right, because once you have 100 servers running on top of your network, there is no going back to changing this network configuration, because now it becomes a mess of downtime and maintenance windows in the middle of the night and weekend work, and nobody wants to hear that. So networking is one of those things that you got to get it right from the beginning in terms of expansion and other things. So we'll talk about that here in a moment. Compute and disk performance. This is where you start to get a ton of different options that you can combine, mix, and match. When it comes to running your application, obviously you're going to need compute power, a certain amount of memory, and a certain amount of disk. And like I said, there's tons of combinations in this case, so we're going to spend some time talking about this as well. Databases. Here in databases, I decided to include a caching layer as well as part of this conversation, as well as a little bit of conversation on NoSQL databases. It's not only relational, because when we think databases, especially us that come from a legacy background in IT, we think of relational databases such as Oracle and Microsoft SQL Server. But just know that in AWS, you have options that go far beyond that. Data ingestion, which is something that we have to consider now in this world of big data and analytics and microservices. We have to consider data ingestion as a separate process. Again, going back to legacy, we used to think of any computer program as input, a process, and then an output. Well, in this case, it's not like that anymore. We're going to just talk about data ingestion, which is the input part of that process, and just concentrate on that. Now, finally, application performance is specific to your applications. We as software developers, we tend to think, oh, it's usually the machine, it's the network or something. It's always somebody else's fault. It's never the fault of our application. So in this case, I'm going to turn that around a little bit and talk about refactors and things that you can do to make your application really take advantage of the underlying network and compute available to you. So with that in mind, let's just jump in right away and talk about networking. As I mentioned before, networking is the one thing that you got to get it right from the very beginning, because networking, once you do it, it's kind of difficult to go back and change it once you have resources deployed on top of the network, because it's going to involve downtime, and nobody wants to hear the word downtime, especially in a production environment. So for networking, here I'm showing you what would be the all style or the best practice recommended in AWS for networking. Where you would have availability zone 1 and AC zone 2. You have those two zones, and the goal here is to create high availability for your applications. What that means is, if you have a load balancer, as in this case, in this diagram, and the load balancer is going to spread the load across these ACs. For those of you that don't know what an AC is, it's an actual physical data center, basically a building, an AWS building full of computers. The problem is, if one of those buildings, for some reason, gets disconnected, they have all kinds of redundancy for networking, but it can happen, and it has happened before, when one of those buildings goes out and your application is going to go down with it. But if you have two ACs with the same copies of your software, now you're protected against one of those data centers going down, and your application is going to still be available. Now, this sounds all great and good in terms of availability of your application, but does it sound good in terms of performance? So moving on here, this is another example where we have, say, a Jenkins server with all the build nodes for that particular server, and this is a single subnet, single AC design. In this case, it doesn't matter if it goes down. This is probably a CI/CD process for a company creating an application. This is probably not a production environment. This is more like a development environment that the coders are going to use to do their business. So in this case, if this thing goes down for 3 to 4 hours, whatever, it really doesn't matter. It's not going to affect revenue or production to the company. So what is the difference between this diagram and the previous one? This is just a single AC, and it's going to be so much faster because the machines are physically in the same building. They're not traversing the network to go to some other building that could be miles away, or could be in another state for all we know. So this is really important in terms of performance. You want your machines to be as physically close as possible, which is the case here. This is something that you want to see in terms of reducing that network latency. So the question now becomes, how do we get the best of both worlds? In other words, how do I get that machine proximity while also maintaining that high availability that we saw in the previous slide about having more than one data center for your application? Well, I like to call it the dual single AC design. And the way this works is that you would have the same load balancer in the middle, and that load balancer is going to access one or two copies of your application, and they're going to be both located in the same data center, if you will, and they're going to be configured either in an active configuration or active passive configuration, depending on your budget and how you want to handle that that load. In this case, my goal is really performance. So you will have a single AC that contains your entire application, that is the server, the backend, possibly a database. Everything is going to be in a single AC. But if that AC goes down, then you will have that option of moving over to the other AC, and you don't have to do anything. You can use Route 53 health checks and load balance health checks as well to realize that, hey, something happens to this data center. Let me go ahead and use the other copy that is available in the other data center to continue to serve my application, and I still keep that performance. So this is what you're looking at right now. It's basically a combination of the previous two diagrams. And in this case, you get both of those benefits where you have the ability to be able to, get your performance as well as maintain high availability. Now, there is one more trick, actually two, that I would like to show you. This one is called placement groups, which is defined as a cluster. A cluster placement group is a logical grouping of instances within a single AC, and that, the benefits of the low latency, as we'll see here in a second. And then a spread placement group places instances on distinct hardware. Let me explain what those things mean. So imagine if you have several machines that they need to talk to each other really fast. Let's say you're talking about an indexer that needs to talk to monitoring nodes, a log aggregation application. If you put them as close together as possible, you're going to get really, really efficient bandwidth usage. And I actually did a test for this. I was filming a course for performance, and I did a test using this thing, and it's just mind-blowing. It basically doubles your network throughput, and it's just amazing. Imagine, being able to run your application and taking advantage of full 10 gigabits for your application. If you have the use case on the code that can take advantage of this networking, it's just beautiful to watch because you're going to get simply the absolute best performance. And as you saw in the definition, you have the option of actually using the same physical hardware for your virtual machines, or if that's too risky for you, because obviously hardware can fail, you can tell the placement group that you want separate physical machines. Like, don't put them too close, because then that would become risky in that case, right? And one more option that I would like to mention is AWS Outposts. The problem with this one is that this is a very, very specific use case. I've only seen it once in the field, but it's just one of those things that is just truly amazing. Let's start with the definition. Outposts is a fully managed service that offers the same AWS infrastructure, services, APIs, and tools to virtually any data center, co-location space, or on-premise facility for a truly consistent hybrid experience. The key word here is hybrid. This is for the main use case is when you have you want to bring the cloud to your data center and reduce that network latency to the minimum, especially if you're connected over a VPN or a direct connect or something like that, and you want to keep that down to single-digit millisecond. This is the way to go. The way this works is that Amazon will come physically to your data center and install a rack with several servers, and that's going to give you the ability to provide to something like storage and EC2 and Lambdas and all those stuff. All those AWS services, they're actually physically running within your data center, so you get like the absolute best possible latency. Like I said, there's not that many use cases out there. I've only seen this used once. And those use cases, they're obviously pretty exciting because you have this amazing connectivity. Imagine being able to use your own data center using the AWS APIs. It's just mind-blowing because you get the flexibility while also maintaining the security of your own private data center where you have your own rules. So it's beautiful to watch. This is one of those great features. Again, I understand that this may not be for everybody. This is probably just for really big enterprise customers. So moving on, we're going to change now, move away from networking discussion, and we're going to talk about compute and disk, because this is when it really starts to affect the regular people like you and I that just want to run an application in the cloud. So these little details really, really matter. So starting right away, I'm going to point you to CloudWatch. At least this is the old way that I used to do things, which means I would take my application and not worry about it. I just run my application in a normal EC2, whether it's Linux or Windows, no problem there. Just get it running. And once your application is running, let's say it's running for 2 weeks, for example, you would have a ton of data in your CloudWatch telling you, hey, this is how much CPU you're using for this past week. This is also how much disk space your application is using, and it's growing at this rate. And with that information, what you can do is you can go back in time and say, okay, it looks like maybe in 6 months the disk is going to be full and I'm going to need to expand. So maybe I'm a little over provisioned in the disk. Maybe I can reduce the disk size. Also, the same goes for the CPU. Like, this machine is always running 10% CPU or less. This also may be over provisioned. Maybe I can get away with a smaller server. Things like that are always very important to consider. In other words, to save costs while keeping the performance level where you want it. But if we move forward here, we have what is known as the Compute Optimizer, which is essentially a machine learning tool that AWS created that replaces what I just said. And the goal here is to be able to determine what machine is best to running this application. Let's say that you're running M5 X large, let's say randomly 8 CPUs and 16 gigs of RAM. And then, this software is going to determine, hey, you're not using all this much memory. You're not using all these CPU. You will benefit from cost savings while keeping the same performance by going down to this or that machine. And this software will do that automatically for you. It's called the EC2 Compute Optimizer. Something to consider. This is a little bit of more detail on the same. Essentially, it even tells you how much money you're going to save by switching to the smaller instance in this case, and it will give you the exact name of the instance that it recommends that you downgrade to if you are over provisioned. And obviously, it's the same if you're over provisioned, right? If you have a too small machine and you have tons of users and processes going on all the time, this thing will more or less tell you, hey, you need to upgrade this because this machine is going to crash if you keep, bumping to the 100% CPU mark there. So something to consider. This is a great tool to save you time when it comes to those tasks of proper sizing of your EC2 fleet in regards to compute and memory resources. Now, when it comes to EBS volume, nobody can help you there. So this one you're going to have to do on your own. As you can see, there's 3 options here that you would consider. Usually the default is the SSD drives that are offered as EBS volume. This is where essentially most of us will pick this option and just roll with it when it comes to storage for AWS, especially for our production servers and things like that. If that's not enough for you, you can then move over to a higher performance provision IOPS option, which is going to be a little bit more expensive, but this is going to be much better control performance drives. When you have this thing attached to your machine, you really don't have to worry too much about their behavior. They're just going to be very consistent. And again, this goes back to the same thing I mentioned about Outposts, is that not many of us are going to have those use cases that have like huge high demands for I/O and just moving data in general back and forth. So I understand that this is not the case for everybody. However, this next option that I'm going to mention, which is the magnetic storage, this could actually benefit a lot of us here simply because this is the cheaper option of the EBS volumes offerings. And this option, what it's going to do for you is it's going to offer storage, kind of like what you would think about S3. When you think about S3 in AWS, you just think, oh, this is cheap storage. But the problem is this cheap storage is a little bit away, quote unquote, away from your machine. So it's not like you can just open a file on S3 directly from your code. You have to copy it first and then you can process it. But if you need it right there, you can. I would highly recommend that you use this magnetic drives as an option because they're just so much cheaper than the other options. And this, of course, is when you need to access a lot of data and you don't really care about the speed at which you're going to access that data because anyways, your process may be slow, right? You may have a slow calculation that doesn't really matter how much time it takes, going to the disk and fetching that data and then writing it back. So something to consider. most of the time, I'm sure most of us are just going to stay within the defaults and choose SSD here. But just know that there are more expensive options, which higher performance, and there's also lower performance, cheaper options as well. Now, there is one more when it comes to storage in EC2, and that's the actual physical drive attached to the machine where your EC2 instance is running. That's called an instance storage volume, also called an ephemeral drive. And let's do the definition here. It provides temporarily block-level storage for many EC2 instances. And this storage consists of a pre-configured and pre-attached blocks of this storage on the same physical server that hosts the EC2 instance for which the block provides storage. The key word in this definition is temporary. You really don't want to make your data rely on a single physical drive. That's like running your entire business off of a laptop, of a personal laptop that, all you need is something bad happening to this one machine and you will lose everything. It's the same case here. You don't want this type of storage to be used for anything that has to do with redundancy. This is limited for performance. So this is what you would use when you have a ton of data. Let's say you need to open a text file and it happens to be, 10 gigabytes, some crazy number of, that would be too much for a text file. But if you move that file first to one of these ephemeral drives, you will feel that the I/O operations of pulling this data is going to be so much faster because this one is actually physically attached to the same machine that you're running. So it does not get any faster than that. Just remember that this is not for the purpose of data durability, right? So you have to understand that if something happens to this drive, if you shut down the machine or something like that, that data is going to disappear. So the use case would be to do something, and then just once you're done, you put it to S3 or some other durable storage. In fact, I have a use case here that I can show you where somebody would use KMS to use encrypted data, and that data is stored in S3. So the first thing you would do is, get your keys, get the data from S3, put it in the machine, and once the data is in the machine, in the ephemeral drive, then you can do the decryption process and then do any kind of operations you want to do on this data, and then once you're done, you put it back to S3. In other words, always assume that the ephemeral drive is going to go away because it will. So never really rely on it for any kind of durability, but it's just amazing when it comes to performance. And it's cheap as well. So this is not something like it's a weird use case. This is something that is cheap that you can certainly take advantage of. This is actually a real life situation that I face where I was downgrading from an N5 machine to an M4, and on paper they look exactly the same. I was like, 64 gigs of RAM, 16 CPUs, they look exactly the same pretty much. But if you notice on the network performance, it says high over here, and at the bottom it says up to 10 gigabit. That wording is a little bit tricky. So the takeaway from this slide is that always prefer the latest instance family in AWS. So in other words, if you're going to use M4, you better just choose M5 if it's available, simply because you're going to get so much better performance, and this is by design. AWS wants to, as soon as a new instance family comes around, they want to make sure that make the previous one less attractive and probably more expensive, just to be able to get rid of all of those old machines and force you into the new machines. So something to keep in mind. I actually faced this situation, and we ended up getting better performance and lower cost by switching to the latest family, as opposed to going to a now quote-unquote legacy M4 in this case. And if you're wondering where I got that information from, it comes from a website called ec2instances.info. I highly recommend it. It's not an official site, so it's not affiliated with AWS or any of us here. But it is good, quick reference if you're looking information about network performance and CPUs and cost and all that stuff around EC2 machines. It's a very quick reference, so just keep that address in mind, ec2instances.info. Now let's talk a little bit about databases. When it comes to databases, you really don't think too much about performance because obviously when it comes to databases, what you want is durability, right? You want your data to be nice and safe and backed up. And if something happens, there's a way around it. So just keep that in mind. There's not that many opportunities to improve when it comes to databases without going into a refactor situation. But yeah, there's a tool called the RDS Performance Insights, which is a database performance tuning and monitoring feature that helps you quickly assess the load of your database and determine when and where to take action. So what this actually means, and I think I have a screenshot here, is that you can pass your SQL queries and look at them in this tool, and then you'll figure out, okay, this SQL query may need to be optimized. It's a little bit slow. Maybe I can break it down into two separate use cases, or even better, how about we just do this SQL query once and then load it into a cache, because anyway, it's not going to change for an hour or two or something like that. And those are things that are really important to consider when thinking about databases. That is not just databases, but you can have a cache layer using something like Elasticache that can save you a ton of performance issues in your database. Something to certainly consider there. And this is actually an example of what I just described, where you have a load balancer that points to an application, and that application may be spread across different ACs. It may have auto scaling and all kinds of things, but in the end, you only have a single database in the back end, and that becomes the bottleneck of your application. So what we propose is at the bottom of the slide, you see that says cache there. That's using the AWS Elasticache service, which you can choose either Redis or Memcache, and you can use these options to reduce the load on your database, which in turn will give you much better performance, because now you're pulling in from the cache, which is usually it's going to be single-digit millisecond as opposed to triple-digit milliseconds or more when you're accessing data directly from the database. So always think about it that when it comes to improving the performance of your database, it may not be directly doing something to it, like changing the EC2 or adding primary key indexes or things like that. It may be just taking the information out of there and put it in a read-only cache, for example. This one is sometimes forgotten, data ingestion, because we tend to think of applications as something that, okay, we just have this application, it takes this data, it makes a process, and then it generates an output. But how about this? How about if we just concentrate on data ingestion? We gather this data, and we don't do anything with this data. So there are several use cases for that. I'm going to show you one of those here in a second. But once we ingest that data, we just concentrate on getting the absolute best performance for data ingestion, and then we can worry about processing a generated output. This is the goal of this particular section. And the use case that I have for you in this case is an e-commerce website, something like Amazon.com, for example, where people are just buying a lot of stuff. But because they're just buying physical items, you get this advantage that once the data is captured, you don't have to worry that this data is going to be processed right away, because somebody needs to physically go into a warehouse and grab a product and put it in a box and ship it to you. So you don't need milliseconds performance for that. You can just capture the data, put it in a database, send an email to the customer saying, hey, thank you for your order. And then, only then, you can worry about processing your documents or whatever it may be. In this case, for example, in this slide, we have a most expensive high-performance queue, tied to Amazon SQS or simple queue service. And those are going to be processing, let's say, high-priority orders, something, somebody paid for urgent shipping or something like that, priority shipping, and you would have this bunch of EC2s just for this purpose. But you don't need hundreds of those or lots of those, because you can just have those in a normal / cheaper queue just for normal processing, and just have like the high performance expensive queue of machines just for processing another set of orders. And of course, I'm saying orders here, but it could be anything. It depends on, of course, on your business case, right? Another option to consider for data ingestion is going to be Amazon Kinesis. And this is when just sending a little JSON document or XML document, when that's not enough, when you actually have like video streaming or audio streaming, like really large files in the gigabytes, then you would switch to Amazon Kinesis, which is going to give you the ability to capture all those gigabytes while not slowing down your machines or cutting on performance. You just send it to this service, and it will kind of take it from there. So again, this is one of those edge use cases, but not so much anymore now that we're all, a lot of us are now ready for video streaming, audio streaming, and podcasting, and all that stuff. And all that data needs to be able to move fast. Imagine, for example, security cameras that they get activated every time there's a motion outside your front door. Those generates, files that are going to be tens of megabytes. It could be in the hundreds of megabytes if it's a few minutes of video. And those files need to be able to move fast because there's a ton of them. So you would use a service like Amazon Kinesis in this case to be able to keep that performance high while capturing that data. This is usually the most forgotten service when it comes to data ingestion, is the Amazon Snowball, which is actually a physical drive that they send to your location, and then you attach this drive to your network, you load it up, and then you put it in a FedEx truck and send it back. It sounds ridiculous at first, like, what am I going to do with this? I have this thing, and it's going to go physically in a truck. How is this going to benefit my performance? Well, that's why I have this slide here to explain that to you. If you have this use case, which is 250 terabytes, and if you happen to have a 1 gigabit network connectivity, I mean, even if you use 50% of that, which would be probably too much because you need other people to be able to work in your company, it says here that you will take like 47 days to be able to move those 250 terabytes on that particular network line over the wire. So 47 days sounds like quite a bit of time. So that's when something like this, you need to consider, this is going to take a significant hit in my network performance. I'm not going to do this to my network. I'm just going to take a physical drive and do it in a few days and, do it with an actual drive, right? And ship it to Amazon, let them take care of it. So again, this is one of those forgotten things that we never really consider when it comes to network performance, but if you have tons and tons of gigabytes to move over the wire, this is when you start to consider a service like this to move the data a lot faster. And finally, we come to application performance. As I mentioned before, most of us don't consider changing our code as a possibility. We say, blame the network or blame the computer. We need faster computers. We never think of, hey, maybe it's our own fault, and we could improve our application performance by changing our code or changing our design overall, which could certainly benefit us in the long term. And that said, I understand that you may have legacy code that you don't even have the source code, or the developer left the company and there's nobody to maintain this code. So there are situations where you cannot do this, but let's talk about what you can do. The things that I recommend is make it run in an immutable infrastructure. What that means is make sure your application can run even if there's other copies of your applications running if possible, because this gives you the ability to put your application in front of a load balancer to be able to process transactions. This is one thing you will hear a lot if you are a software developer and you are mindful of the microservices architecture. Something else would be don't hard code any dependencies or settings. So if you have an application, don't make it point to a specific server and then do that in code. Make sure you do that in a configuration file somewhere that it could be easily changed, because once you migrate an application from your data center to the cloud, now, once you move an application to the cloud, now you have all these issues here about, okay, now it's different routing, different security settings, and all this stuff, and your application may crash because of the completely different environment. So, yeah, if you can get away with it, don't hard code anything into your application. Just make sure everything is in a configurable file that you can change. And it brings me to the thing about microservices. So when it comes to microservices, those are usually the absolute best things that you can do when it comes to taking an application to the cloud. Because a microservice is basically a transactional unit. it will take an input, it will generate something, and put a record in a database or generate a file, and then be done and be ready to process some more. So if you have those in on-prem and you want to move those to the cloud, this is usually the best case, because these are things that you can turn into a Docker container, put it in a Kubernetes cluster or something like that. And this is absolutely the best of the best possibility that you can do for your design. This is like the best. If you can get away with going back to changing your code and turn it into a microservice, split your application into 3 or 4 parts, be sure to take advantage of that, because that gives you tons and tons of flexibility when it comes to performance. And that brings me to the Q&A. Hopefully we have a bunch of questions here.
Yes, we do, Carlos. Great stuff. And I'd like to remind the audience that we can answer questions up until about 5 minutes to the top of the hour in order to give you a short break before the next presentation. So send them on in. Okay, let's move to the Q&A box. First question. Carlos, can I still create microservices even if I don't have the source code of my legacy application?
That is a great question, and it's very much in line with what I just said. In this case, what I would say, I had a situation in the past where I had a legacy Java application that was running on Tomcat web server. And the challenge was, can we move this application to the cloud without making any changes to it? As long as this application doesn't have any settings issues or configuration problems, the answer is an absolute yes, and let me explain why. If you go to Docker Hub, there is an available image on a Docker container for Tomcat web server precisely. So I took this image and I created a Docker file that combines the legacy application with this new Dockerized Tomcat web server, and I created a custom Docker image for myself, in this case for this legacy application. And then the application was able to be moved into a cluster in AWS, a Docker cluster. And that was like, is the best case scenario, because you're basically turning a legacy app into a microservices app by doing it this way, and you get all the benefits of the cloud, such as scaling, load balancing, and high availability. So absolutely. Yeah.
Okay, I'd like to remind the audience we still have plenty of time for questions, so send them on in. And here's one from Nadu. He says, with immutable infrastructure, what challenges will you face?
Well, that's really, I love this question. When it comes to immutable, the main challenge, number one, is going to be maintaining that immutable architecture, meaning that you're going to have a snapshot of a machine, and you're going to have a process to maintain this image all the time. So what I recommend is to just have it as generic as possible, your particular immutable infrastructure. And then once it's generic, then let's say you have an EC2 server, for example, let's say it's Linux. Once it boots, during the booting process, you can say, okay, now this machine is booting, and like I said, it's 100% immutable. There's not even, you don't even have access to changing anything in the machine. So when the machine boots, it will load settings. It's going to load credentials that it needs, from AWS parameter store or somewhere like that. Once it has settings and credentials, you can also load data. If it needs data, you can load that from S3 at runtime or at boot time. And then once this application is running, that's it. You can put it behind a load balancer or something like that. Of course, like I said, I say it very easy here, but these are challenges that you're going to certainly face, because you need to have all these processes, maybe perhaps in a CI/CD pipeline or something like that. So yeah, there are certain challenges. You need to be skilled in various tools to be able to manage these challenges, but it's certainly possible to do.
Okay, great. Here's a question from Joe. He asked, which Tomcat container on hub.docker.com did you use?
When it comes to that, I can't remember right now. I think it was Tomcat 5.0. They have, like, for legacy reasons in there, they have several of these. They go as far back as whatever it was, the earliest version of Tomcat. The thing about Tomcat is that it's going to be associated to the Java version that you're running. So if you're running, let's say, an application that was coded in Java 9, for example, you want to be able to use a Tomcat image that is compatible with Java 9 in this case. So you have those issues to consider, and there's tons and tons of versions, but they all more or less perform the same way. You open it up, it's an image, and it's going to give you a folder, usually called Web Apps, and this is where you're going to put your code or your Web Archive application. You're going to put it in there in your own custom Docker file, and you're off to the races, and that's pretty much the way it's going to be for all the various versions out there. But to answer your question specifically, always try to stick to the official releases, in this case from Apache. For example, I see something here about many results for Tomcat, Joe. And in that case, just stick to the official version release from Apache. Don't just take some random Docker image that says Tomcat. Just look for the ones that are provided by the official vendor.
Okay, great. And as we're going through these questions, I'd like to remind the audience that the slides are available in the console on the right side of the area in case you want to check out those resources and slides. Here's a question from Juan. What tools do you recommend to monitor performance of migrated legacy apps?
Oh, that's interesting. The first one that comes to mind is not free. It's called New Relic. And what you can do, if we stick to the legacy Tomcat example that we're talking about, New Relic will give you like an agent, like a jar file that you can put inside the container as well when you do the deployment. And it will give you insights of what's going on in there, how much memory is being used, how is the Java virtual machine performance, and all that. Certainly I would recommend New Relic. If you need a free tool to be able to do this, then the one that I use is called Prometheus, and it pairs really well with Grafana. And those two offerings are just now, I believe in the past few months, made available as part of AWS offerings. But again, these are open source tools that you can certainly use for monitoring any kind of application. They'll give you a little agent that you can install on your machine, and then that agent will take care of gathering the metrics and then passing it on to an aggregation tool that then you can use to do like a dashboard and see your metrics, see your real-time CPU and then disk consumption and all that stuff. So those are my two recommendations in this case, Prometheus, Grafana, or the New Relic offering.
Okay, great. And as we go through these questions, I'd like to solicit some more, so send them on in. I'd also like to remind the audience that the event is being recorded, and they will receive a follow-up email when the replay is available for on-demand viewing. Now let's get back to the questions. Here's one from Donald. He asks, how common is it for content creators to use AWS?
I've seen it in several occasions. Number one would be using AWS S3 service, the storage service. So let's say, for example, that you have content, and we're talking about static content here. So you have your website, and you have a portfolio that you want to show to your clients or your potential customers in the future. What you would have is you can use S3, and there's a feature in there that's specific to content distribution. It's called the static website. So you can use Amazon as a host for your static website, and it's a great idea because it's so much cheaper storage that you're getting. So yeah, using something like S3 is a really good solution to distribute large files and in a reliable way, because you can also combine that with something like CloudFront, which is a content distribution network that you can put in front of S3 meaning that let's say that you have a 1 gigabyte video file talking about your product or what you do, like a video introduction of yourself, and you want that video to play in a reliable manner across the globe. The same performance if you're watching in Asia, Europe, or America. The way to do it would be to use a content distribution network that will make virtual copies of your content across the globe to make it available as close as possible to the user. So for a content creator, I highly recommend something like S3 and CloudFront. Those are the things that I would look into in this particular use case.
All right, great. I'd remind the audience we have plenty of time for more questions, so send them on in. And regarding one of those earlier questions about Tomcat, Joe has reported, he must have done a web search, and he reports 36,318 results for Tomcat.
Oh, absolutely.
Usage.
Yes. There's plenty out there. The thing about Docker Hub is that you will have a lot of people just putting their own custom designs out there, I have this Tomcat and I put in a monitoring and logging tool built into it because after all, it's an open source tool. You can make changes. But what I recommend is don't touch those because you don't know what could be in there. That's not a very secure practice. So I only download Docker images that are provided by the official vendor, that this comes from the Apache Foundation. So it will be Tomcat. Okay, I'm only going to use those images that come from this vendor because, anybody else, yes, there's tons of great offerings that you can use for your own development environment or something like that, but I would not use anything for production that doesn't come from an official source, in this case, the vendor being, Apache. That's there's still going to be quite a few options based on versions and releases and build numbers, but you're going to be narrowed that down significantly once you stick to only official versions.
Okay, great answer. I'd like to remind the audience that we will be picking the winner of the Nintendo Switch at the end of the event, the next presentation, and you must be present to win. So hang in there and get a chance to win that gaming console. Back to the questions. Here's one. Carlos, should I use Elastic Cache or DynamoDB?
The answer to that, let's see. Well, if it's a brand new application that you're doing, I would certainly say DynamoDB. Because obviously, if you're just coding a brand new application right now, you're not 100% sure about what the performance bottlenecks are going to be unless you have like an exact metric. Okay, this is going to be this many users, right, that are going to be visiting my application. So, but yeah, DynamoDB is a pretty safe way to go because if the performance is going to be single-digit milliseconds to access your data, assuming, of course, you're accessing the data using the proper index. So if you have an invoice, you want to be able to access that invoice by the order number, for example. You don't want to be looking into the details of that order because then that becomes a SQL very slow search, and that's going to give you a performance hit. So as long as you stick to the indexes, DynamoDB is the way to go. But let's say you have a legacy application that you want to change. So in that case, I would recommend something like Redis using Elasticache. It's just so much better to be able to pull that data once, put it in a cache, and then just deliver it from the cache to the users with the maximum amount of performance. So there's a use case for everyone. Not to say, that Elasticache is not an option for a new development. That certainly is. But I try to stick to, something like DynamoDB. It already stores the document in JSON format, and if you have a UI team that's already using JavaScript and you give them a JSON document with the data, they're going to be very thankful because, it's a lot easier for them to manage, and it's a lot more flexible there in that sense to be able to add fields or remove fields as needed, which would not be the case if you have a strict RDS relational database, in this case, and if it would be a legacy application. So Elasticache, certainly if you're dealing with refactoring legacy, and DynamoDB if you wanted to do a new one.
Okay. Looks like we might have time for 2 or 3 more questions, so let's get to the ones that we have. The next one reads, can I resize an almost full EBS volume using CloudWatch alarms?
Let's see. There's a couple of parts to this question. Resize, you can absolutely do it. The way I would do it is first you would need some kind of custom metrics, something reporting from the computer itself, sending data to CloudWatch saying, hey, this disk is 80% full or something like that. And you can then turn that metric into an alarm and say, any server that hits 80% full, just send me an alarm or an email saying, hey, this disk is about to be full. We need to resize it. Yes, at that point in time, you can send a command, let's say using something like AWS SSM, you can send a command saying, hey, modify this particular drive. I want this drive to add another 100 gigabytes, for example. You can certainly do that, but just be aware that whether you're running Linux or Windows, you're going to need a separate solution to be able to tell the operating system, hey, there's an additional 100 gigabytes that just came online, and you will need to be able to tell the operating system to resize the partition to be able to take advantage of this new space that just showed up there, because they're not going to know by itself. Even that goes beyond AWS scope in this case, but the operating system is not going to know that you have an extra 100 gigabytes in there until you actually send some sort of notification and then a command to be able to expand that data partition.
Okay, looks like we have time for one more question, and it comes from Mamdao. He says, what do you expect in the next gen set of tools in AWS for virtual networking?
Oh, that's great. I expect a lot more expansion in the terms of software-defined infrastructure. That's always going to be expanding. Right now, CloudFormation is still king because it's been around for so many years. But if you saw the earlier presentation from Stephen, he talks about the Cloud Development Kit. AWS is pushing really hard on this approach because it comes baked in with best networking practices. So being able to write code, let's say in Python or something like that, to be able to write that code and generate a proper network infrastructure following best practices is just amazing. So yeah, that's the direction that we're going to keep going, and they keep improving on that product. And yeah, absolutely, that's the way to go when it comes to infrastructure as code going forward is the Cloud Development Kit.
Okay, well, thanks again, Carlos. Great stuff on the presentation and those detailed questions.
Awesome, glad to help.